Good morning and welcome to another edition of Learning Online. Today we're going to be talking about finding the area of a regular polygon with what we call the apothem. And the reason why we're trying to find areas of regular polygons is because we don't have a specific formula for, say, a pentagon or a hexagon or a heptagon or an octagon or a nonagon. All these are different shapes. I mean, we have squares, rectangles, triangles, we have all that, but nothing for this. So what we need to do is use some of the information as part of these figures in order to come up with a formula that we can use to solve. Now, if you notice on all of these, we have a side length for any of the sides, so that's right here. Okay. And if you notice, we've got this length right here, and that goes for here and also here. This is kind of a height of a triangle. Okay, if you notice that we've broken up these pentagons, hexagons, and heptagons into triangles. The pentagon, there's 5 sides, broken up into 5 triangles. Hexagon, 6 sides, broken up into 6 triangles. Heptagon, 7 sides, broken up into 7 triangles. Well, we can find the area of a triangle, but we got to figure out what that particular length is for A. A is called the apothem. Okay, it's a Greek term. It's basically the height of, or basically a perpendicular segment from the center of the polygon all the way to the side of the polygon. So if you notice, it goes from the center all the way to the side, and it's perpendicular. It's a Greek term. I'm not expecting you to remember specifically how to say it, but just remember A means apothem. When we do this, we can use the area formula for triangles in order to help us out here. Now remember, triangles are base times height divided by 2. Well, the base in this case is S, so here's S. The height is A, and if we multiply those and divide by 2, we get one triangle. But then we need to multiply by how many triangles there are. That's what gives us the area of these regular figures. Now if you forgot what a regular polygon is, a regular polygon is a polygon that has all the sides the same, all the angles the same. That way we know that if we find the area of one, we can find all of them. So when we're looking at this, the area of a regular polygon is given by, there's 3 different formulas you could use, although I'm going to tell you which one I think is my favorite. You can use 1/2 times A, the apothem, times S, the side length, times N, the number of sides. You could also use A is equal to 1/2 the apothem times the perimeter. If they give you the perimeter, you can use that, and that's a little faster. Or my favorite, I like to do this because I like the division at the very end. So A times S times N, and then divide by 2. You're still using the triangle formula, but instead of doing that 1/2, which can be very confusing to people, I just do divide by 2 at the end, and it seems like it goes faster. It's the same way with triangles, so I like this a little bit more. Okay, so let's put this into practice. I'm going to show you some examples of regular polygons with some of the numbers inside, and we're just going to use the formula. This should be hopefully a very easy lesson today. Tomorrow we're going to talk about finding the area of a regular polygon when we don't have the apothem, and how we're going to use trig to help us out with that. So let's look. Here I have, it looks like a heptagon. It looks like it's got 7 sides. It looks like I've got the segment that's perpendicular right here all the way to the center. That's called the apothem. The side length of each side is 7.7 all the way around. So 7.7, 7.7, 7.7, 7.7, and so forth. So what we want to do is we want to use this formula. A times S times N divided by 2. So we know the apothem is 8. We know that the side length is 7.7. And we know the number of sides is 7. There are 7 sides in this figure. Okay, so we have to have all 3 of those numbers in order to begin. So if I do 8 times 7.7 times 7, and then divide by 2, I multiply the top first, 431.2, then divide by 2, I get 215.6. Now I believe on the assignment there are no units, so you don't have to worry about that today. But if you saw units, you'd have to put square units. So if it was inches, square inches. Centimeters, square centimeters. But for today's assignment, I do not believe that there are any on there, so you don't have to worry. Let's try another one. Here we have a hexagon, 6 sides. The apothem is 13.9. The side length is 16. So let's go through this whole process. Again, same formula. Formula is going to be the same for every single problem. So let's see, apothem times side length times the number of sides. We know that the apothem is 13.9, the side length is 16, and n is 6 because that's how many sides there are. So if I plug that in, 13.9 times 16 times 6, then divided by 2, I get 1334.4 divided by 2, and my final answer is 667.2. Please don't forget to divide by 2 on each problem because that's going to make a huge difference. Let's do one more example. You'll notice on this example here, I didn't give you the shape, I just gave you the name of the shape. So you have to know your names of shapes. If you forget, no worries, look it up online. So if you forgot what a nonagon is, look it up and type in nonagon in Google, and it'll probably tell you how many sides it has. Okay, so if you forget, don't let that stop you. Okay, on some of the problems, let's see, they might give you the number of sides, some of them might give you the name. So make sure you know you can find it either way. So again, using the same formula here, the apothem they gave us, the side length they gave us, a nonagon, if you didn't know, had 9 sides. So the 8 is the A, S is 5.8, N is 9. So plugging it in, I get 8 times 5.8 times 9, that's 417.6. Then I divide by 2, that's 208.8. So make sure you're using this formula, and if you want to use the other formula, you can, but I like this one. It seems to be simple, pretty easy to use. Make sure you're able to complete the assignment. Again, if you have any questions, I'll be on from 10 to 11 and from 1 to 2 to answer any questions you might have. So feel free to join us on Zoom. Make sure you check Google Classroom for the link, and I hope to see you soon.